Hi, I'm Peter O'Reilly. I'm going to show you how to set up a method file for tensile testing on the Zwick. So the first thing is to go to User Shortcut. So open User Shortcut. Open a folder which has been created for you. I'm going to open somebody else's here, Tatiana's. Open this. And the type of file you need is Text Expert Test Instruction. So that's the type of one to open. I'm going to go down. I'm going to open this one here. So open this. So as it opens up, you should hear a clicking noise at the back of the machine where the software is communicating with the hardware. Just a bit slow to open. Okay. So that's it. So close. So if this figure here corresponds to the figure on the crosshead on the machine at the knife edge, then you switch on. So I switch on. So now we're going to bring you through it. This is the force on the load cell. This is the crosshead movement, and this is the grip to grip separation. First thing, go into Wizard, Test Definition, Tensile. Start position, you want to have this box ticked and this box ticked. We're going to apply a preload to take the slack out of the sample. And that's why we have the gauge length is corrected. The little box will right up here. The gauge length is corrected after the preload is reached. So preload, I'm going to put on a preload, and I'm going to put a preload on this sample of 0.1 newtons. It's a 100 newton load cell. I'm going to go at a speed of 5 millimeters a minute to the preload. I'm going to wait at the preload, so it says wait for hold time. I'm going to use position control to wait. Don't use force controlled, use position controlled. I'm going to wait for 5 seconds. If I have too much slack in the sample, it'll time out. So this is 100 seconds set to timeout. And zero the force after the preload. That's a personal decision which I've taken. Some people say no. So I'm going to zero the force after the preload. So they're the parameters. There, okay. Next thing is specimen data. This sample is a flat sample. See all the options here? So say flat specimen. Specimen thickness, 1 millimeter. Specimen width, 3. Okay. Leave that at 1 and that at 0. Conditioning phase. We're going to condition the sample, but I'm going to actually do this conditioning of this sample in the test phase. I'm going to apply 5 cycles to this, and I'm going to go number of cycles 5, and it's going to go up to a force of 0.1 newtons, and then come down to a force of 0.05. It's going to hold for 5 seconds at the 0.1 newtons. It's going to hold for 5 seconds at the 0.05. It's going to go 0.1 newtons. Tick this box, hold time, 5 seconds. Then down to 0.05. Tick this box, hold time, 5 seconds. In each case, position controlled. And then the speed of the actual cycles, again in position control, 10 millimeters a minute. So that's it. That's the cyclic loading. So, okay. So that's just conditioning cycles before we start the test. Next thing is to do the actual test, load application phase. Load application up to the end of the test. Position controlled, 2 millimeters a minute. Okay, so that's the actual tensile test. Then how do we decide the test is over? End of test. We decide the test is over when the test has dropped to 50% of the maximum load experienced by the sample. So that's a decision. Sometimes people say 80, 90%. So in this case, 50% force shutdown of the maximum load experienced by the sample. We'll say the test is over. Results. This is for a results PDF, which you won't be actually using, so you can ignore that. Break investigation. This is the data acquisition at the break. That's standard. You can just leave those figures as they are. Just leave them as they are like that. 55, 10, 10. Actions after test. We don't need any actions after the test. We're going to bring the crosshead back manually. Now this is the actual data acquisition during the test. So it'll take data every 10 microns or every 0.1 seconds, whichever is the sooner, and it'll take displacement, force and time data. So these figures are more than accurate if you have 10 microns for standard travel and 0.1 seconds for time. Control parameters, you just need this box ticked. It's to do with the closed loop control of the machine. Control position, that's all. Media layout, don't need any of this. Parameters for the report, you won't be getting that report. Into series, okay, almost ready to start the test. right click here, configure dialog. What we want is it to ask us each time the actual thickness and width of the sample, because they may vary. So I just want the thickness and width of the sample in there. So I don't want all these. I do want those two. Oh, sorry, I'll get them back. Okay, specimen width, thickness. Specimen thickness across, specimen width across. That one. Okay, so I want a request for this before the test, a mandatory request before the test. I want to force input those two parameters. We say OK. Right, so now it'll ask us each time, we'll have to fill in the values there. This is your graph. You can change this, configure curve graph. You can make the y-axis whatever you want. You can make the x-axis whatever you want. I'm going to say force for the y-axis and time for the x-axis. If you make the upper limit fairly small, like 2 newtons, and the upper limit 100 seconds for the time, it'll auto-scale and grow the graph to suit your test. The next thing is you want to save the method file, so save as. Choose the test program here, ZP2. Choose a name and make sure it's been saved in the correct folder. Okay, so test program, choose the name, make sure it's going in there. The next thing you want to do is save the series in advance. Save as. Click the series. This will save the series of tests with all the graphs in advance, continuously updated after each sample. You can replay the series. So click series. Again, give it a name, maybe with today's date. Make sure it's going in the right place. Okay. And the last thing is you want to set up the raw data files. File, export interfaces. Choose this one. Choose this one. Don't tick any of those. You can find your file path there, your directory, clicking this button, and then just name the file. That's a very long name. You don't need a name like that, just a short name. Then you have this box ticked. It'll automatically number the samples. It'll optimize it for Excel and set the file extension to XLS. So they're the boxes you want ticked. You don't need those ticked. Parameters, you want the preload and the parallel specimen length. Okay, so the parallel specimen length is there. Okay, I'll leave those in. Channels, you want standard travel millimeters, standard force newtons, strain percentage, stress megapascals, time seconds. They'll all come up in your raw data file. Moment in time of export at end of test. Okay, so that's all set up to do the raw data. So then we're just basically zero the force. We have a sample in, zero the force. I haven't showed you how to reference the flattens, so I have to do that separately. Into machine though, and just check here, I'll just show you. All the machine data is in here. If you hit expand it, there's the force, 100 newtons load cell is linked. So that should always be linked across to the correct load cell. You have a force of 100 newton load cell in at the moment. And crosshead, double click that. This is where you do the reference. But I can show you that a separate time. So we close that, and we're ready to start. You just click this. So I'm going to close this now. Save changes, no. And I'm going to close this. And I'm going to stop.